Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 10, 2025, just yesterday. It introduces a method that can speed up video LLMs by 3 times, with only a tiny 2% drop in accuracy. The paper is titled Multi-Granular Spatio-Temporal Token Merging for Training Free Acceleration of Video LLMs. And as we'll see, its ability to handle different types of video content is really what sets it apart. The authors propose a new, training-free way to merge video tokens by looking at redundant information in both space and time. Also, the authors shared their implementation on GitHub, so for anyone who wants to dig into the code, you can find the STTM repository online. It looks like it's the initial code drop, so you'll find the core files to see how their token merging approach is implemented. Alright, so to really see how this spatio-temporal token merging method stacks up, the first figure gives us a great visual comparison. It pits their approach, called STTM, against several others at 2 different token budgets, which is the percentage of video data the model keeps after merging. The radar charts show that STTM, the solid green line, maintains very high accuracy across different video types, while others struggle. And importantly, this method is query agnostic, meaning the video is compressed once, before any questions are asked, which is key for efficient reuse. So, how does this actually work? Well, this next diagram gives us a great look under the hood. The spatio-temporal token merging method is a 2-step process. First, there's spatial merging. For each video frame, the model looks for redundant areas. Think of a static background. It combines those similar tokens into bigger blocks. But for areas with fine details, it keeps the smaller tokens. Next, in temporal merging, it looks for similar tokens across consecutive frames and merges them, essentially tracking an object or region through time. This smart, 2-stage compression is key. Building on that idea, this figure illustrates that first spatial merging stage. It uses what's called a quad tree structure, which is a clever way of breaking down an image into a grid of 4 and then recursively breaking down each of those squares. The model performs a coarse-to-fine search. If a large block is very similar to its 4 smaller parts, it just keeps the large block. But if there's a lot of detail, indicated by a low similarity score, it keeps the smaller, more detailed blocks. This is how it creates those efficient multi-granular tokens. Drilling down into why this method works so well, this table really breaks it down. It shows the 2 components, spatial merging, or STM, and temporal merging, called TTM. Looking at the rows, you see that using either one on its own preserves accuracy but doesn't compress the video that much. But when you combine them, that's the 3rd row. The number of video tokens drops to around 26%, while accuracy stays near 98%. This really highlights the synergy between the 2 steps, proving their sequential, 2-stage approach is the key. So to see this in action, this next figure provides a fantastic visualization. In the top example, you have text on a static background. The merging process smartly removes almost all the redundant black space, while keeping the fine-grained tokens for the text itself. You can see how in later frames almost nothing is left, because the temporal merging recognized the text was static. The bottom example shows a more dynamic scene. And again, static parts like the green screen are heavily compressed, while key details like faces and hands are preserved. This really drives home how the method intelligently keeps what matters. So, as those visualizations show, this method is incredibly effective. In conclusion, the key takeaway is that this spatio-temporal token merging offers a powerful, training-free way to speed up video LLMs. By smartly merging redundant areas first spatially, then temporally, it achieves up to a 3 times speed up with minimal accuracy loss. Crucially, it's query agnostic. This means the compressed video's key value cache, its computed memory of the video, can be reused for multiple questions, saving a ton of work. Alright, that's all for this week's AI Research Roundup. Thanks for tuning in.